Welcome to the Real Python Podcast. This is episode 175. Python 3.12 is here. Our regular guests Geir Arne, Hjelle and Christopher Trudeau return to discuss the new version. Geir Arne coordinated a series of preview articles with several members of the Real Python team this year. And his annual piece, published on Monday, October 2nd, titled Python 3.12, Cool New Features for You to Try. And Christopher's video course posted the next day, covering the topics from the article with visual examples of Python 3.12 in action. Geir Arne and Christopher collaborated to create code examples of the new features. We discuss better error messaging, more intuitive f-strings, subinterpreters, the Linux perf profiler, improved typing syntax, and more. We dig into the updates and offer advice on incorporating them into your projects. We also consider when you should start running Python 3.12. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. All right. Well, it's Python 3.12 week here at Real Python, and as has been an annual tradition, we have Geir Arne, Hjelle, and Christopher Trudeau back on the show. So welcome back, Geir Arne.
Thank you, Chris. I like this tradition. It's fun to hang out.
Yeah, it's very cool. And Christopher Trudeau is back again.
You try not to stress the again in that. Eh?
I'll hit it really hard.
Yeah.
So we've kind of divided up some of the features that are part of Python 3.12 and going to go through them kind of back and forth and discuss them. Geir Arne has worked on a preview article that came out earlier this week, kind of been an annual tradition also, previewing a lot of the features that are in it. Along with that, Christopher just finished his video course that covers a lot of the same features. And so those are both available on the site. And I'll talk about them a little bit more in the show as the video spotlight this week. One thing that is a little bit different is this year, Geir Arne continued the tradition of having preview articles, getting people prepped to understand what's coming out with 3.12. This year, it sounds like you had several more preview articles and maybe some help. Is that right?
Right. Yeah. So we've been, I guess, we started this last year. So for the 3.11, we started doing a few in-depth articles about certain features. And last year I wrote, I think we did 3 preview articles plus the full article. But this year we got the whole team involved. So this year we actually did 5 of these preview tutorials about the different features. So we'll add some links to all of those as well, where we kind of go really deep about the new features.
Yeah.
And then in this week's tutorial, we kind of more just show the highlights of each of the features.
Yeah, and we'll get a chance to drill in a little bit into them and then also add our commentary on the different features as we go. But yeah, those are nice deep dives, and we'll also get a chance to highlight some of the additional authors there.
Yep.
So generally that worked well. Do you feel like you're going to do that for the next release? Not to preempt any of that for you.
Right. I guess we haven't talked about it within the team, but my feeling is that it was very successful, and I think it was fun to involve the whole team in this, and we kind of got to play off each other a little bit more and so on. And it's the preview articles are they're good for me as sort of like research into the full article.
Okay.
And I think it's good for all the readers as well, for kind of having the option to go in depth for the features they are interested in.
Nice.
Yeah, and I think they were particularly important this year because so much of the 3.12 stuff is sort of internal.
Right.
When we did the course, we were going to talk briefly about things like subinterpreters. Most people aren't going to interact with these things. You get a couple slides that say this is what it is, but if it's the thing you're interested in, then you've got this depth you can go off and you can dig in as much as you want. So I think it works really well for different levels of interest in the audience.
Yeah, you can kind of pick and choose a little bit and drill in on stuff. You get a real chance to to focus on things that you may be of more interest for a particular audience. So, you guys ready to dig in then to some of the features? We're going to kind of go back and forth between Geir Arne and Christopher on covering these things.
Sure.
All right. So, Geir Arne, tell me how we've been continuing to get better and better error messages.
Right. Yeah. So, as you may remember, in Python 3.10, there was kind of the start of an initiative of rewriting many of the error messages, especially syntax errors.
Yeah.
This was something that was kind of made possible by the switch to the new parser, where we could kind of be more precise with things. So in 3.10, there was a lot of error messages were improved. They got more informative and they got also more precise, so they could actually point out the line where something bad was happening. For 3.11, it was slightly different, where they rather improved the tracebacks themselves and added these fun little squiggles into the tracebacks. In 3.12, it's back to just improving some of the error messages. And in particular, several of them relate to imports and things like this, so they can kind of nudge you towards, did you forget to import some standard library module, or did you mess up the syntax for importing, and those kind of things. So it's just many of these small the user conveniences or life improvements that you're kind of getting from this, where the messages just become much easier to work with. So that there's, I think, 3 in particular about imports.
Okay.
So one is just if you try to use something in a standard library module and you don't import it, it will essentially just say, did you forget to import whatever module you used? So say if you just type math.py, it will say, did you forget to import math? And then there's this thing where you can import just certain names from a module, where you do something like from math import pi. But if you mess up the order of this and say import pi from math, which kind of sounds natural, then it will actually tell you that, no, you need to switch the order there and use from math import pi instead.
Yeah, I think Christopher was saying before that is the way sometimes it's worded in other languages.
Oh, yeah, that might be, yeah.
Yeah, it's a common mistake for people coming from other places.
Yeah.
And the third kind of related improved error message they have is that if you're then doing one of these import certain names and you misspell the name, it's usually able to tell you what you misspelled. So for instance, if I do something like from math import pi, but I spell it py, it will ask me, did you mean pi as in pi instead, or things like this. So
okay. It has to be within the ballpark of what it could guess, I guess.
Yeah, and this is something they introduced in 3.10, where they had these suggestion features. So it's doing some kind of fuzzy string search, essentially, on the available names. So, yeah, if it finds something that's fairly close, then it will use it as a suggestion. The final error message they have improved relates to classes. And if you're using some instance attributes, so typically you have self.something, but you forget the self. Part, it's usually able to just ask, did you really mean just to say radius or something, or did you mean self.radius? Again, it's just nudging you in the right direction to kind of help you see at a glance what's wrong.
Yeah, these are such quality of life improvements for beginners and intermediates, or anybody who makes typos.
Right.
For everybody. Quite frankly, it is the most used feature for me of 3.10 and 3.11, and I suspect it will be for 3.12. I know the walrus exists. I know they added it. I've never used it, but did you mean shows up pretty much every day of the week I code. Yeah.
Yeah.
So they just continue the nice work of improving these. I suspect we'll see more of these also in 3.13 and later. And this was one of those things where we did an in-depth feature on.
Yeah.
So the Python 3.12 preview, we called it Ever Better Error Messages, since this seems to be the continuing trend. And in that one, Martin Broyce was the author, and he did a really nice deep dive into the C code to kind of show off a little bit about how the suggestion feature is implemented and where it kind of finds suggestions and so on. So if you're interested in just really digging into what it takes to create these error messages, that preview article is really nice.
Yeah. I talked for a while with Pablo Galindo Salgado about this back in, I think when 3.10 was coming out. And it was really fun because we kind of were able to dig into a little bit how the peg parser work. And I believe he's still pretty deeply involved in this. Like this is one of his babies in this whole project. So
yeah, Pablo, I think, has implemented all of these improved error messages also now for 3.12. So
awesome. So Chris, tell me what's going on with f-strings this year.
So f-strings have been around for a while now. They were actually introduced in Python 3.6. And that's before, so Geir Arne already sort of made the mention of the new parser, the peg, that showed up in 3.9-ish, 3.10, depending on how you want to draw that line. And so when they introduced f-strings into Python, this was before that parser. And the parser they were using at the time it wasn't powerful enough to do f-strings. So what they did was they had the parser identify it as a string and then pass it off to a secondary parser. And that secondary parser would actually do the f-string parsing. Well, the new peg, or it's not, I guess it's not that new anymore, but newish peg relative, is capable of parsing the f-strings and more. So what they've done in this release is essentially to replace the parsing code with peg parsing code. This primarily means less code for the maintainers and a cleaner experience on the back end. But it has some side effects that are beneficial. So when doing this change, a few of the limitations that the old specialty parser had were to be removed. So for example, the first one is how nested quotes work. So with the old parser, an f-string had to follow the same rules as a regular string, which means if you wanted to use quotes inside a brace expression, they had to be different kinds of quotes than the surrounding ones, right? So double quotes on the outside and single on the inside, say. So particularly like if you were trying to get at like a value inside of a dictionary.
Yeah.
And so this restriction has been removed. So in 3.12, what's inside of those brace brackets is treated as a separate idea than the string itself. And so you can use double quotes inside of those brace expressions if you like. I'm not really sure I like this.
Okay.
Part of that may just be I'm old and change bothers me. I don't know. But I'm so used to what a string looks like that this just doesn't scan for me. But, maybe I'll get there eventually. One side effect of this is it's breaking linters and syntax highlighters, as there's really no way to differentiate between 3.12 code and earlier code just by loading it. They're either going to have to put like a flag into the linter, or the linters aren't going to be able to identify the old problem anymore. And we've seen it, even the automatic checkers we have for the code in articles for on Real Python had to be fudged a little bit to get the articles to publish because of exactly this problem. So another restriction that's been removed, kind of similar, is you didn't used to be able to use backslashes inside of those brace expressions. I didn't even know this restriction was there. I'd never tried it before. But the example given in most code is, say you wanted to do a /n join inside of a brace expression. Before 3.12, you had to do it outside, put it in a variable, and then use the variable inside. Now inside, you can do it.
Okay.
Another one, what I'm sort of like, okay, whatever. You can also now nest f-strings. I'm not sure what the use case for this is, but if you want f-strings in your f-strings, hey, go for it. The commonality across all of these really is the idea that what's in the brace expression is now equivalent to an actual Python expression, rather than being this weird little subset that it was before. And so you get most of the power of the language inside the brace and don't have to think about it as being a special case.
Yeah.
The one last restriction that got removed, and this one I can definitely get behind, is you can now put comments inside of the brace expressions. So this is particularly handy if you're doing, say, like a triple quoted multi-line f-string and you want to put a comment in the brace explaining what you're doing. For example, why you wanted to nest a bunch of f-strings together, you should put a comment on that.
Right.
Well, now you can do that, and that's a nice little benefit.
Yeah, the fact that it can kind of do some code inside of an f-string, it might be nice to have that commented, like why you're doing it there. And I could think of some other like compilation thing where like some function is tying a bunch of strings together, and that is maybe why they got nested. I don't know, but that is interesting.
Yeah, I could see there's probably extreme cases of things like building regexes and stuff like that where you might want to nest something. I'm sure there's a case for it. I'm not. It sounds like I'm down on it. I don't expect I'll be using it anytime soon, but it doesn't hurt anything for it to be there. And like I said, I think it really is just sort of a design decision side effect of going, hey, this is now an expression and therefore it can parse like any other expression. rather than I'm guessing, but I doubt the core maintainer sat around and said, you know what we really need? Nested F strings. So I suspect it's just a benefit of how things have changed.
Cool. So Geir Arne, there's an article on this one too, right? A deeper dive?
Yes, exactly. So Leodanis Pozo Ramos has written the preview article on more intuitive and consistent F strings. And I think I've read somewhere that Pablo was involved in this one as well, Pablo Galindez-Delgado, the core developer, on the F strings. And I read somewhere that this nesting thing, it's definitely not something they tell people you should really be doing this.
Oh, okay.
It was more, they just figured out we don't need to restrict it. And then probably some linters will jump in and tell people, please don't do this.
All right.
Kind of just moving the restriction out.
Here's the really powerful gun. Please don't point it at your toes.
Exactly. There we go.
Nice. So Geir Arne, you wanted to talk about a couple optimizations, one being the comprehension inlining.
Right. So I guess last year for 3.11, all the buzz was about the faster CPython project and how Python was getting faster.
Yeah.
And that's been, in a sense, more quiet this year for 3.12. And I think the 3.12 is definitely faster than 3.11, but not with the same amount as 3.11 was faster than 3.10. But the project is continuing with several people working full-time on it. There's a couple of things I'll just highlight. One of them is kind of the highlight from last year, was the specialized adaptive interpreter.
Okay.
Which essentially just means that they improved the CPython interpreter so that it could change and adapt the bytecode, which is the code that's actually running, during execution, so that it would kind of notice things like, okay, you keep multiplying float numbers. So instead of running a regular multiplication operation, we'll do the float multiplication operation, which is faster.
Okay.
So it kind of specializes things like this. Well, it was introduced last year, and then it's just been improved for 3.12. And of course, when you just improve stuff, you don't get the same headlines. They've done some good stuff there. The process of using the specialized adaptive interpreter in 3.11 was that it had a quickening step and then a specialization step. And the quickening step was essentially the interpreter just looking at the code being executed and at some point noticing, okay, this bytecode keeps being executed. So we'll mark it as a candidate for specialization. So it kind of just noticed the interpreter. In the future, you should do something with this. For 3.12, they have just removed the quickening step and just all the bytecodes are available for specialization. So it kind of simplified that process a little bit. And then for the specialization part, they just added a bunch more bytecodes that can be specialized. So they kind of started with 3.11 with sort of like the simple things, like if you're just adding some numbers, then you can add 2 floats or you can add 2 integers, and the operation internally is quite different. So they could kind of specialize for each of those. And they've just been adding many more of these specialized operations for 3.12. Then the other one I want to talk about, and this is kind of the optimization thing that got its own PEP this year, PEP 709. It's about inlining comprehensions. So it's about list comprehensions, dictionary comprehensions, set comprehensions. I don't think they included generator expressions this time.
Okay.
But the other comprehensions, or the regular comprehensions. And this is, again, mainly just an internal thing. But when Python sees a list comprehension, what it actually does is that it rewrites the comprehension as a nested function. And then into the bytecode, it kind of inserts this function call to call the comprehension function that it has created. That's been the case now up until Python 3.11. For Python 3.12, it's inlining the comprehension instead, which means that it doesn't make the nested function. It just pops all the code into wherever that comprehension is called. The nice thing with creating the function is that it makes things very clean and simple in terms of keeping the namespaces separate and so on, so that your variables inside of the comprehension don't leak out. So you can have an X. You can have a variable, say, name, that's outside of comprehension, and then you run your comprehension and you have a name for naming names inside the comprehension, and that name doesn't overwrite the one that's on the outside.
Okay.
That comes for free when the comprehension is a function, because that's how functions work. You have their own, they have their own namespace. So when they did the inlining, they kind of need to do some tricks to make sure that we still have the same behavior with the namespaces and so on. But this they've been able to do. So they've then gotten these comprehensions to run inline. And the big bonus for us as users is that comprehensions are faster. We see the big difference for short iterables, because then you have most of the overhead for calling the nested function in the Python 3.11. And I found some examples where I do really long iterables where the 3.12 was actually slightly slower. I don't think that's because of the comprehension per se, but that some other operations have gotten slightly slower, while others are faster and so on. But what they've seen on the big benchmarks is that they see a speed up of 10 to 15% on the general comprehensions.
Okay.
So there should be at least some bonus for this. There are actually a few tiny changes that you might notice, but this is essentially just how the local namespace things changes. And if you get errors inside of your comprehension, the traceback will be slightly different, because in 3.11, you actually can see this nested function in the traceback, and that will be gone now. But apart from that, you shouldn't really notice any difference in 3.12 with comprehensions. So this is another one of those that's kind of internal.
Yeah, under the hood.
Under the hood kind of changes, but it's part of these steps towards ever faster Python.
Yeah, kind of digging further into more under the hood stuff. Chris, you want to talk about the support for subinterpreters?
Yeah, I think this is hoods plural.
Okay.
So depending on our listeners' depth of knowledge, I'm going to go off on a little tangent here. So in order to give the right background. So Python's an interpreted language, and let's contrast that to a compiled language. So in a compiled language like C, you're using a compiler to translate your code into the machine language that's directly used by your computer. In an interpreted language like Python, it's got some sort of virtual machine mechanism that's running your script. Now, it might compile it down into an intermediary bytecode or something, but it's running that and not the computer's main language. The advantage to this is scripts can run anywhere, because as long as you've got an interpreter, you can run it without it needing to be recompiled. It's the interpreter's responsibility to talk the computer's language. The disadvantage of this is it tends to be slower, because you're putting an abstraction layer between your code and the actual machine. So when you type Python on the command line, you're invoking that interpreter. And there's actually several different Python interpreters out there. And so when we say Python, we're actually being vague. Sometimes we mean the language, and sometimes we mean the interpreter.
Right.
And the interpreter that most people are using is CPython. And so when Geir Arne makes the comment that this is 10 or 15% faster, what he's actually meaning is there were performance improvements in the CPython interpreter. That mechanism doesn't affect other third-party interpreters, right? So we're almost there, most of the background. So when you type Python, that first interpreter gets spawned, and we're going to call that the main interpreter. And that interpreter can create copies of itself, and these copies are called subinterpreters. And you do this when you create multiple processes for writing concurrent code. Now, one problem that's common in concurrent code is how to handle the situation where you've got two processes that want to modify the same value at the same time. And if it happens in the wrong order, you'll get bugs, you'll get wrong values, you might get a mix of the two values, not just the race condition of who wins, but like a muddled mess in between. So to get around this in parallel coding, we put locks in place to make sure that that kind of thing doesn't happen. And this problem is so common that Python has the lock that wins out over all other locks called the global interpreter lock, which we've talked about probably to death on this show.
Sure.
So this lock is trying to make sure that certain global shared values aren't exposed to this kind of race condition. Now, if you put a lock like this in place, you're losing some of that parallelism, because now everybody's waiting on that lock. And so now to the core of what I'm actually talking about, PEP 684 and PEP 554. Both of these are about doing work with these subinterpreters and the GIL. So PEP 684 is moving the GIL into the subinterpreter. And that means each interpreter will be able to work completely independently of all others. So GIL actually isn't a GIL anymore, it's a SIL, because the lock is just at that interpreter level. So this could mean a big boost to concurrency. Now, the GIL's there to protect different extensions from stomping all over each other. So a big part of this work really is changing things so that an extension can say, hey, I know how to use this. And if the extension doesn't say, hey, I know how to use this, then the old way is going to be used so that nothing gets broken. We don't want to go through Python 2.7 to 3 again. So PEP 684 is all internal to CPython. PEP 554 intends to actually expose all this work in the Python language. And I say intends because this one is targeted for Python 3.13.
Okay.
So they're making this change as a 2-step process. So this is all somewhat related. There's a whole bunch of work going on right now in trying to get rid of the GIL or contain the GIL or use the GIL less. And it's making Python more capable with concurrent code. And this is a big, long-term, ongoing project. So if you write Python code and only write Python code, you will not see a difference in this in 3.12. In 3.13, you'll get access to some stuff that you wouldn't have had access to before. If you're using things like NumPy, when they get around to start taking advantage of this, you might actually see some speed up. And of course, if you're an extension writer, then you've got work to do.
Yeah, I'm thinking that this groundwork that's being laid really is reinforcing the idea that if you are a package maintainer or you do those kinds of projects that are, doing things that travel into C or into Rust or something like that, that you're going to really want to be testing these on your code over the next year.
Yeah, for sure. And the flip side of it is, this is a sign of the maturity of the language, right? Like it's starting to be used in such big ways that these things are becoming important, right? Like Python 1 was a little fiddly scripting thing on your local box and no one would have cared about this, right? Now it's being used in huge multi-concurrent beasts of software.
Yeah.
And so we're running up into the limitations of the language, and the core maintainers are doing a good job trying to figure out how to get us to that next level and keep the language growing in its usage to be deployed on massive parallelism. So we'll get there.
Cool. This one, there was another preview article, and this one was by a previous guest of ours, Jim Anderson, who'd been on the show. I'm hoping to get him back on the show, actually, to talk a little bit more about maybe some of this stuff. But that sounds like that one, it came out just like a week or two ago, right, Geir Arne?
Yeah, it's quite recent. And that was, well, first of all, it was great to have Jim back to write an article for us.
Yeah.
And he did a great job of kind of writing about future Python code. So some of this, Chris mentioned this for 3.12, but Jim also notes some of the examples that should be possible in 3.13 or a later version of Python. So it's a really interesting read.
Yeah, definitely. And again, if you want to learn a little bit more about what's happening internally, it's going to be a really good resource for you. Geir Arne, do you want to talk about, again, this one has another company article with it talking about measuring performance, especially if you have Linux.
Right. So this is one of those things that you may not care about, or it might be just what you needed. So it's, well, the short tagline is just that Python now supports the Linux perf profiler. To give a slight overview there. So first of all, a profiler is just a tool that you use to monitor the performance, and you can diagnose the performance of your scripts. And if you then profile your code, then you'll kind of get some kind of report that will say something about either how fast things are running, how much CPU things are using, how much memory is being used, and so on. There are different kind of profilers.
Yeah.
And Python has long supported different profiling tools, including a very simple tool called timeit in the standard library, and also cprofile, which is a regular profiler in the standard library. And there have been some third-party tools and so on. So now the perf profiler, that's one of sort of like the big players in Linux, and it's actually built into the Linux kernel. So it's really tightly integrated into the operating system. If you've been trying to profile Python code with perf, what actually has happened so far is that it hasn't really been useful, because perf will just tell you that, well, there's this C function called eval frame default that's running for 99% of your time. So
it's all in this one box.
may want to do something with that function. Exactly. And that function is actually just your CPython interpreter that's just evaluating Python code. The actual Python code hasn't been available for perf. It's just seeing the C program that you're running. So it kind of comes back to what Chris was explaining about Python being the interpreted language. And when you're running Python code, you're actually running the interpreter. So what they've done now for Python 3.12, and again, this has been Pablo Galindo Salgado has been involved in this. They've added support for perf by using a technique called trampolining or trampoline instrumentation. And mainly it's just a small hook that you need to activate, and then it will expose the Python calls to perf. So that when you set everything up, then you can actually use this profiler and you'll see things like, okay, it's spending 90% of the time in this function. So that might be where you want to go look for optimizations and so on. Yeah, as I said, this is something that may be just what you need, or it may not be that interesting. But again, if you want to learn more about this, we have a fantastic deep dive article that Bartosz Seksinski wrote. So he dives deep into how to set up the Linux perf profiler, which is not completely trivial. So it's already a good resource just for getting this thing up and running. Then it shows how you can run it on different Python scripts, ways that you can kind of look at different functions, set up some benchmark scripts. And then also he goes through several tools that you can use to look at the reports that you get from these profiling runs. And to top it off, we also added an article about profiling in general, showing some of these other tools that we mentioned earlier, like the C profile and time it and so on.
Yeah.
So there's lots of stuff to dig into there.
Yeah. In fact, I think after that article came out that Bartosz did about general profilers, that's when Emery Berger reached out to me to talk about scaling.
Right. Yeah.
He said, Bartosz, you should check this out. And then he referred him to me. And so we had that episode, which was very enlightening if you want to do a much deeper dive into profiling and what's capable of some of these more advanced tools for seeing how your code runs and maybe finding where bottlenecks are. Christopher, you want to talk about Immortal objects?
Sure. We touched on this not that long ago. We talked about it in episode 171.
Yeah.
But it's a 3.12 change, and so I'll go over it quickly just so, for completion's sake. He says, knowing he never does anything quickly. So CPython uses a internal structure that corresponds to every object in your Python code. And of course, everything in Python is an object. I'm going to get a t-shirt printed. So
maybe I should have a bell.
Maybe,
and I can
yes.
just ring it
there you
every
go.
time
Yes,
said
that's right.
on the show.
So this CPython structure includes both the data for the object, which kind of makes sense, but it also has metadata about the object. And one thing that metadata is used for is tracking how many other objects are referencing your object. And that gets used to know whether or not, if nobody's using it anymore, we can garbage collect it. So that's the first bit. The second bit is objects that don't change. We're going to call those immutable. Immutable objects can still go out of scope, which means immutable objects have to have mutable metadata, because the metadata has to continue counting whether or not this thing can get removed or not. So enter immortal objects. PEP 683 identifies a subset of immutable objects that actually typically last for the lifetime of the interpreter. And one of those is the none object, because even none is an object in Python.
Yeah.
And so an immutable object that lives for the lifetime of the interpreter, that mutable metadata section, it means you're never going to garbage collect it. So there's this subset of objects that live forever, and they've got this extra overhead. So what essentially is being done here is a flag is being added to identify them as not just immutable, but immortal. And then they'll never need to be garbage collected ever. And that means some of the metadata can be optimized away. You don't have to worry about things like cache invalidation. You don't have to worry about synchronizing them across processes, because the two processes aren't going to change them, so you don't have to sync that. And the removal of some of that metadata saves memory. So this PEP came out of the folks at Instagram. They're a Django shop, and they've seen significant improvements to their startup times and memory usage just by implementing this optimization. So long live Immortal objects. Completely internal change. Again, unless you're writing an extension, you will never see this, but they're at scale. This is a performance improvement.
Be aware, certain objects are gods.
Yes, yeah. There's a very dated Buffy the Vampire Slayer reference in there, but I suspect it's too niche, so I'm just going to leave it alone.
Okay. For this week's video course spotlight, I want to remind you that Christopher Trudeau has created a video course all about this week's topic. In this video course, you'll learn about the new features and improvements in Python 3.12. Improvements to f-strings. More, did you mean error messages? New functionality in the standard library, including features for pathlib and itertools, additions to static typing, and changes in the CPython interpreter that continue the work to speed up Python. If you'd like a guided video tour of the new features in Python 3.12, this is the course for you. Like all the video courses on Real Python, the course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. Geir Arne, you want to talk a little bit about some changes with the calendar?
Right. So this is a fairly small addition that they're doing to the calendar module. And I must admit that one of the reasons I want to highlight it is to just highlight that Python has a calendar module, which may not be that everyone knows about. So if you're working with dates in Python, you're probably using the datetime module, which is kind of what provides date and datetime classes that you can use to represent, well, dates and dates with timestamps. In the calendar module, they've kind of sort of like adding stuff that is more towards, say the public use, in a sense, the less technical use of dates. So it can just show a calendar. If you run the Python -m calendar, that's how you run the module. It will actually just print a calendar in your terminal. So there's some neat functions there, and then they have some functions for just calculating days of the week. They have the list of months in your locale, so in your language, and things like this are inside of this calendar module. The one little thing they're adding now for Python 3.12 is that they're adding constants for each of the weekdays, Monday, Tuesday, Wednesday, and so on, and for the months. And these are enumerations, which is essentially a collection of constants, and that they're represented by numbers as well. So you can kind of, if you want to, you can both refer to, say, the 10th month, and you'll get October back. You can refer to October and kind of get the number 10 back, or you can just iterate over all the months and things like this. So it's just making the calendar module slightly more useful by adding these. Not a big deal at all, but it's a fun little addition to the language.
This one really surprised me. I don't understand how we've gotten to Python 3.12 without having this already. It was sort of like, what do you mean we didn't have this? All right, get it eventually, whatever. That's fine.
So yeah, beforehand, you would have been importing something potentially to help you with this?
I think there were third-party tools that did it. I suspect I've got code where I've done it by hand myself.
Yeah,
and they had they had like the months available in a list and things like this before, but
okay,
the constants are kind of the new stuff. Yeah,
nice.
Or the enumeration. I think even the weekdays they had as constants, but not related to each other.
All right. Well, maybe that will remove some imports there potentially for some people down the road. Speaking of which, this is one I really enjoyed your coverage of this in the video course, Christopher. The thing about batched and itertools.
Yeah, it's a nice little. Again, it's a small little improvement, but it's one of those that's kind of useful. You never used it. There's a third-party tool called More Itertools. You should check it out. It's got all the kinds of things that you kind of think should be in itertools but don't exist. And one of them is something called chunked, and chunked takes an iterable and returns some values grouped together. So this is really handy if you want to take a bunch of data and present it in, say, rows. You chunk based on the number of columns you want. I've used it a bunch for writing things like that in the web. And now, because of Python 3.12, you no longer need it for that, because the same concept has been built into the actual itertools library. They've named it batched instead of chunked, but it essentially does the same thing. So let's take the new calendar.month enum and say you wanted to print out the months by quarters. You could call iter.batched, passing in the calendar.month enum and a value of 3, which is the size of the group, and you'd get back 4 tuples, 1 for each quarter. And each of the tuple would then contain the 3 group months. And it's handy for, say, printing it out to the screen or whatever, and formatting, that kind of stuff. So useful little thing.
Yeah, I could really see how it'd be handy, with layout stuff for Django and whatever.
I've used chunked a lot on in order to do rows and columns of like, hey, here's your video library. You don't just put a straight listing of videos. You put 3 or 4 columns wide. If you're using Bootstrap underneath, and you've got that concept of rows and columns inside of Bootstrap, you're almost always doing something in your view in order to format it, in order for Bootstrap to be able to process it that way. So yeah, this is useful little functionality, and it may, for me at least, it's going to remove 1 extra dependency because it'll be built in.
Nice. So Geir Arne, we got to talk about types again. It seems every release we got to have some new stuff, which is great. In fact, it looks like they're simplifying some stuff, which has always actually been a bit of a theme in some ways, making maybe the types look a little bit cleaner as we go through it. Is that the case this time too?
Yes, definitely. And yes, you hint at so that there's always new type improvements in Python, it seems like. So the whole support for static typing was added back in 3.5, and then they've kind of gradually improved it. And I think one of the guiding principles is that they kind of want to try things out before committing to them fully.
Oh, yeah.
So it feels like we can kind of broadly categorize the new type changes into two things. One is kind of we're getting new features, and those are typically added into this typing standard library where you need to import stuff to try it out and so on. And it's, I guess the idea is that it's easier to remove things from there. In addition, stuff that's in a library you can also backport. So they're using a third-party library called typing extensions.
Okay.
Where you can put features so that you can use them even in earlier Python versions. So even though you add a feature in Python 3.12 to typing, if you're on Python 3.9, you can import that same feature from typing extensions so that you can actually start using it earlier or on older Pythons. Then the second kind of category of new things in typing are when they're changing the syntax. So they're actually changing the Python language to support the typing stuff. And some examples where they did this was when, I think that was back in 3.9, we could start using lowercase list and lowercase dict to annotate types, lists and dictionaries. Before 3.9, we need to import capital or uppercase list and uppercase dictionary to do the same kind of annotations. And then in 3.10, they added specialized syntax for doing unions and so on. So in 3.12, they are simplifying and adding dedicated syntax for type variables. The type variables, then we're kind of getting into somewhat advanced type territory. But I think that the new syntax makes a lot of sense when you just get used to it. So to go back a little bit, a type variable is a variable that can represent different types during type checking. So for concrete example, say that you have a function that can work with a list of elements. And often that you don't care too much about what type of elements those are. Your function can potentially work with all of them. So just to do a very simple example of this, you may have a function that can pull out the first element of a list. And then if you want to add a type annotation to that, you want to annotate what's the return type of this. Well, the return type would be whatever is the type of your list elements. And mostly when you're working with lists, you have some kind of homogeneous list. You have a list of numbers, or you have a list of strings, or you have a list of booleans, or things like this. So what you want is to be able to say that, okay, my function can work for any kind of list, but if you can identify that it's a list of integers, then I know the return type of my first function will be an integer. Or if it's a list of strings, then the return type will be a string.
Right.
So one way to do this would just be to write out many, many type hints for all the different types, but it's much better to use a type variable. So what you'll do then is that you'll just declare a variable. So up until 3.12, you needed to import something called type_var from typing, and then you need to declare that, say, t is a commonly used variable for this, but it could really be anything. But say t equals a type_var. And then inside your type hints, you can then say that elements is of type list of t. And then my function returns t. So then the t will stand in for whatever function of whatever type that your list happens to be. So then it can type check if it knows that, okay, now you're passing a list of integers into first, the type checker knows that it returns an integer and so on. Really, this type variable is just something that can stand in for, in general, any type, and then there are ways you can constrain it to, okay, this function actually just works for different kind of number types, so integer, floats, and complex, for instance, or something. Okay, so up until now, as I said, you need to import this type_var, you need to declare it beforehand, and so on. In Python 3.12, they introduce a new syntax, which looks a little bit weird the first time you see it, but you're now allowed to write in your function definition, you'll write something like def, and then first. And then before the parentheses where you have your parameters, you'll add a square bracket and then just declare your type variable. So it will be def first square bracket t, and then you end that square bracket, and then you can list your parameters afterwards. And just by putting the t in there, you're saying that, okay, this function is what's called a generic function. It can work on different types, and this t is a t type variable that I want to use inside of my type hints in the function. Yeah, the first time you see it, there's kind of, okay, what is this square bracket doing there? But I think my feeling is at least that this is nicer than trying to figure out all the type var stuff before. It kind of looks fairly clean, actually. And you can use the same syntax when you're defining a class. If you have a class that's kind of depending on the type in the same sense, a generic class as they're called.
Okay.
In that case, you'll do the class and then the name of your class. So for instance, if you have a stack, for instance, you can do class stack and then square brackets t or whatever type variable name you want to use, and so on. These type variables, as I briefly mentioned, they can be constrained to only be of certain types. So if you want to constrain your type variable, then inside of that square brackets where you declare it, you just add a literal tuple of types. So you can write something like t colon and then parentheses, since it's a tuple, int, comma float, comma complex, for instance. Then you say that, okay, this is type variable, but it can only be either an int, a float, or a complex. It can't be any other type.
Okay.
And the final thing you can do is that it can also be bounded, which means that it can be of a certain type or any of its subtypes or subclasses. So you could say something like this thing is bounded to be a string or any subclass of string. The syntax for that is also using a colon, so that will just be t colon and then the type that you're bounding it to. So t colon str, for instance, for strings. The final place where you can use this type variable syntax is for type aliases. So type alias is also something that's been supported since the beginning. Type alias is just a different name for a type, often something you'd use if you have some kind of nested or complex type. So if you have, say, a list of tuples that are, say, a tuple of a callable and an integer or something like this, it gets both hard to keep typing this out. It gets hard to read. It kind of gets, typically, you get lost in the technical details of what is this type really. And then maybe it is just really, I don't know, some list of plugins or something like this.
Okay.
So then you could just create a new type that says this is a list of plugins. So these type aliases can also be generic in the sense that they can depend on these type variables. For type variables, you're now allowed to start using this t as well. But since that doesn't really... so far a type alias has just been a regular assignment. So you just say this list of plugins equals and then the type. But then that's not valid Python syntax to suddenly throw in a square bracket on that. So they added a new sort of like statement where you write type in front of your new variable name, and that creates a type alias. So you'll write something like type space list of plugins equals then whatever that type is. So this is actually a new soft keyword, as they call it. So type already exists in Python as something you can. It's a built-in that you can call to just check the type of an object.
Yeah.
So here they're giving it a second use essentially, and by using what they call a soft keyword, it means that it's just a keyword in certain contexts. So it's a keyword when you're putting it in front of a variable, but then you're still allowed to use the type built in anywhere else. So again, it's just simplifying and making more explicit syntax for this, especially the generic type aliases where you can use the type variable. It looks much neater now than it used to.
I think it will help projects that have to accept lots of different types, projects like that do testing and things like that, for them to be able to add this sort of functionality. Hopefully it'll make their code look a little cleaner with the annotations in it and improve it.
I think whenever you kind of end up with your own kind of containers, so your list-like structures, these kind of things are super helpful.
Cool.
And I can note for this one as well, we have a preview article that kind of goes more in depth than we can do in the main article, and that's one that I wrote myself.
Yeah, that one just came out also right before this.
Yep.
Great. Christopher, you have an update of some new feature for Pathlib.
I think I've mentioned on the show before that I'm a fan of Pathlib. It's been around a while, but somehow I was a late adopter of it. If you're fortunate enough to be fully in the Python 3 world, you really should be using it instead of os.path for all your file name needs. Common thing you do with a directory is to figure out what's in the directory. There is a method in Pathlib for iterating on a directory, but it doesn't descend. It only looks at the level of the path. So historically, if you wanted to descend the file tree, you write a little recursive function and then, basically call yourself with this iterator. So that always felt like a weird bit of a shortcoming because the OS module actually has a walk method that descends for you. Well, now 3.12, so does Pathlib.
Nice.
So you can walk a path object that is a directory and you get back a series of tuples, very, very similar to how OS walk did it. Each tuple contains another path object for the directory inside of it. And then, so it'd be, the first one you're walking. And then the second item is a list of the names of subdirectories. And then the third item is a list of the names of file names inside of it. So you essentially can see a whole picture. And then the call to walk descends the entire tree this way, meaning you no longer have to write a recursive function. You can just iterate over it.
Yeah.
There's an optional parameter called top down, which defaults to true. If you want, you can set it to false, and then it'll walk the tree bottom up instead. So off the top of my head, I can think of at least 3 of my libraries that would have some code removed by having this functionality.
Nice.
Now they're libraries, and I have to wait until it's a new language feature, and so until it's ported across. But a couple of years from now, I'll have some lines of code to remove thanks to this addition.
Yeah, I think this is really nice, even though that was always a great practice exercise in recursion.
Yes, it's your standard exercise. Yes, so I don't have to teach you what a tree is. Go walk a directory. Yes.
Yeah. So Geir Arne, we're going to leave the last one for you here. This one is digging a little bit further into typing, but this one has a little bit more to do with if you're overriding existing. I guess, is it mostly just methods, or is it other things that it could be overridden? Okay.
It's for methods. So when you're doing inheritance with classes and those kind of things. Yeah, so this is another typing feature. And the previous one I talked about with type variables, that's a new syntax. So that's something you really need to wait until you can use Python 3.12 for. While this override decorator is one of these new features that's added into typing and also backported into typing extensions, so you can start using it also on older versions of Python already. The idea with the override decorator is that you can mark off whenever you're overriding a method in a parent class. And this might seem a little bit weird because you don't need to do this, and Python kind of knows that you are already overriding. So why? what benefits do we get from marking this explicitly? And the thinking is that when you're overriding a method, a type checker doesn't really know if that's what you meant to do or if it was just an accident because you didn't know there was a method in the parent class and so on. So by adding this explicit decorator for it, then you can kind of get the extra support from the type checker where it can tell you that, okay, you claim that you're overriding a method here, but you're really not, or the other way around, you are overriding a method, but you're not saying so. And
right. Or making changes to the original.
Right.
Potentially, yeah.
Yeah.
Okay.
So the idea then is that one example of this would be, say that you have a bank account class and it has your deposit and withdraw methods, and then you might have a specializing class like a savings account or something where you override, so you re-implement the withdraw method. So that would be one occasion where you can put this override decorator in it. And what the static type checker can then help you with is essentially, typically if you're doing some refactoring or if you're kind of getting a little bit forgetful about what was the actual API or things like this, it can help you. For instance, if you're renaming a method in a class, but you're forgetting to rename the corresponding method in the subclasses,
okay,
then it will notice that, okay, now this thing is no longer overriding, even though you're saying you are. Or similarly, if you happen to just misspell a name or something like this, it will kind of have the same effect. And then the other way around, if you add a new method in a class that makes an existing method in a subclass suddenly be an override, then it can also warn you about those kind of things. So in total, this is not a big deal, but it kind of gives you that extra trust, especially if you're doing some refactoring and things like this. You'll get a little bit more support.
Yeah, I could see it as like a team thing also, like,
right.
Where there's several people touching this code and not wanting them to, I don't know, you had put a word in there, sort of a defensive measure.
Right. Yeah, exactly. Yeah. And this kind of feature is something that has existed in many other languages already. So
okay.
Java, C++, and a host of others already have a similar way to mark methods that are overrides. And there's actually also been a somewhat popular third-party library called Overrides for Python, where you can also mark your overriding methods. But this library don't work with static type checkers. It actually checks things and forces things during the runtime. So this one then is slightly different, but
yeah, there's a name clash in Django as well. Django uses it to override settings. So if you want to change the settings for, like, global settings for a particular function, you can override the settings pieces. So it's gonna, I don't know whether that's gonna cause issues or not. It'll be interesting to see. But
okay. I guess there'll be an update on either side for that.
It shouldn't matter. It's not a keyword. So as long as you got the right library gone, and if you want to use them both, you'll just have to do an as. But that was my first thing when I saw it. I'm like, why are they doing that? That's a Django thing. And then, it's a typing thing. Now I understand what they're doing. Yeah.
Yeah. So we usually, as we wrap up our review here of what's happening with Python 3.12, we always kind of talk about, what's your plan on as far as upgrading? And several of these things people have mentioned already, like, hey, I think I might be using this and so forth. Also maybe providing some advice to others, like, is this a good time to upgrade? And what are things that they need to keep in mind? Do you want to go first, Christopher?
Sure. I think we could almost just copy and paste what we said last year, right? It's it's more or less the same, right? Like, there's always a little bit of risk when you upgrade.
Yep.
Honestly, I've been playing with it for a while now. I haven't seen any issues. We've been playing with 3 different release candidates. Have not run into any problems myself. So if you're coding for yourself and for your own purposes, there's absolutely no reason not to, as far as I'm concerned. If you're maintaining libraries, you're into that weird middle ground of, I still have not pulled in any 3.7 features into any of my libraries because I'm still trying to test across compatibility across all of them, right? So as we move up to just supporting just 3.8 and then 3.9, then you start absorbing these things, but that process is different. And I'm not an extension person. I think if I was an extension person, I think this might make me nervous. I think I definitely want to go and dig in because a lot of the internals have been touched.
Yeah. lots of changes under the hood, as we have repeated multiple times. So, yeah. What's your advice, Geir Arne?
Yeah, I definitely agree with Chris. It's kind of upgrading your interpreter to 3.12, especially in just your local development. Feels like, yeah, it's nice, just something to start playing with. And similarly, if you're doing library maintenance, then at least start testing on Python 3.12 already, so that you kind of know that things will work. If you're in charge of production environment and those kind of things, I'd probably be a little bit more careful. Definitely set up all your tests first, make sure they are running. It's probably okay to just wait for the first few bug fix releases. They'll come out within a few months to have things up and running. What is probably the biggest thing to look out for when you're updating is if you have dependencies to other libraries.
Okay.
And in particular, libraries that use C extensions, because the C extensions need to be compiled for each version of Python.
Yeah.
So you can't use, say, a NumPy that's compiled for Python 3.11. You can't just take that and use it on 3.12. It needs to be compiled specifically for 3.12. So it may take some time before all those packages that you're depending on have compiled their 3.12 versions. NumPy has already done this, so if you're on the latest version of NumPy, you're free to just start running with it, but there might be others that are not already there.
I've definitely noticed that in the past with a lot of data science libraries that they can get very, I don't want to say stuck. Sometimes they're much slower to move through the updated versions because of just the stack of dependencies and the sort of the way things were built. So occasionally, this is more of a problem with me with, I think, my Mac at the time because of the compilation of some of these other libraries to run on the M1 Mac architecture took a while to kind of get that going. I think that's getting better, but I don't know if that's across. Is it, I don't want to point the a finger at one particular area, but I feel like that's the area that I've struggled when trying to run projects.
Right. Yeah, I think that, data science is probably the area where you're using most of these C extension packages.
Yeah.
So they're more exposed in that way. My feeling is that there's been much more, say, consciousness about this for the last couple of releases, so that they kind of been faster to just get these packages up and running. And I think most of the big ones will probably have wheels in place even before the release. As I said, NumPy has been out for at least a month or something with support for Python 3.12.
Good.
But that's definitely one thing to just look out for. If your dependencies are not 3.12 ready, then it's hard for you to be 3.12 ready.
Yeah, and some of them are interdependent too, right? So,
right.
If your stuff is built on top of NumPy stuff, you kind of have to wait for the NumPy folks to do it, right? So you're always into that space. So there's a bit of a chicken and egg problem sometimes.
Yeah. But apart from that, I would be happy to upgrade to Python 3.12. I think the biggest reason, so say if you switch it around and say what are the incentives to upgrade, the biggest ones are probably just getting the improved error messages, getting that
quality of life
stuff, and a little bit, it might be slightly faster. Typically, you would probably need to wait to start taking advantage of the new syntaxes, like some of the f-string stuff or the type variables.
Right. You might see some stuff in your linters, as we mentioned,
Right. So, and unless you're kind of just developing an application where you have full control on the environment, then by all means start playing with the 3.12 features. But otherwise, you probably, it pays to be more conservative so that your code will still run on older interpreters as well.
Yeah. As we've gone through this list of features, we mentioned Pablo Galindo Salgado multiple times. I know that he's very involved in the core development. Are there other names that you would want to call out that have featured some of these PEPs that we've mentioned? I'll try to keep a list of the PEPs also. If people want to dive into them.
Yeah, so Eric Snow has done a great job on the whole subinterpreters, immortal objects things, and kind of been doing a lot of work on that route towards kind of separating out the GIL a little bit for the subinterpreters. And for the typing stuff, there's a whole team there, but especially Hjelle Sistra, I think his name might be pronounced something close to that, I hope, has been doing a lot of work on that lately. So he's been involved both with the type variable syntax and some of the other things that are happening there. And then in general, the whole faster C Python team, that's where Mark Shannon has kind of been leading, but there's a whole team there as well. So there's many people that have been doing a lot of work on this one, this release of Python. And I think kind of we've been talking a lot about how there's a lot of internal changes.
Yep.
And I think these are kind of just promising an interesting future where they're kind of laying the groundwork for some of the other things happening in the future as well. So it's fun to follow what's happening there.
Yeah, definitely. Well, again, if you haven't dug into some of these articles and tutorials that we've mentioned, there's, again, 5 of these sort of preview ones that do the deep dives into typing and the F strings, the Linux perf profiler, and the subinterpreters, and even better or ever better error messages. So thanks again to everybody on the Real Python team for all your great work on that. And thanks again, Geir Arne, for organizing all of that coverage this year.
Yeah, it's been fun.
I personally want to thank you for handling the typing stuff because,
Yes, you're welcome. Anytime.
Well, thanks again, Christopher, coming on the show again.
See you soon.
All right. And thanks again, Geir Arne. Good to talk to you.
Thank you. Take care.
I want to thank Geir Arne Hjelle and Christopher Trudeau for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.